Welcome to Techstination. Joining us is Pablo Vidarte, the CEO and founder of a company called BIO, B-I-O-O. Thank you for joining us, Pablo.
Thank you, Fred. It's a pleasure.
Very, very interesting company. I'm going to let you describe it for us. What do you do?
We generate electricity from nature itself. And actually, we do it in a very interesting way because we can even obtain energy or electricity from plants' photosynthesis. And actually, we do it in other ways as well, obtaining energy from soil or even treating plants as biological switches, always without harming any living being.
Wow. So how do you do that? Give us this, if there's a simple explanation.
What we do, it's a biological battery that basically collects all the free electrons that are expelled in any organic environment, for example, an average grass. There are always microorganisms that are eating organic molecules, and in that process, a lot of electrons are set free. So in nature, all those electrons just go away, they get lost, they recombine with other molecules. But what we do is to catch those electrons. And when we do that, we basically generate an electric current and we're able to power, well, basically whatever you want. And those organic molecules, which is after all this fuel of the whole battery, could be obtained from, well, anything, even dragged from rainwater or any living being on there, which expels organic matter.
One might assume that these amounts of electricity are minuscule. Is that correct? And how do you harness enough to make it worthwhile here?
Mm-hmm. Well, actually, what we are generating, it's way more than we expected. But the thing is that right now, we are not really competing against solar panels, for example. So in terms of how much we produce, it depends on the battery that we use. For example, we've made like 11 different batteries, and we are actually competing in a great way in some specific fields. For example, in agriculture, when powering sensors, we're even able to give a discharge of 100 milliseconds of 50 watts, which is a lot, by the way. And when talking about our products, which are focused for implementation of this technology on green fields such as gardens or parks, we are right now able to generate enough energy for automatic irrigation systems, and the next version is going to be able to power light points in those parks and green areas.
It sounds like you can possibly have plants, soil, generating electricity to produce light to help them grow and creates kind of a cycle that way. Is that a possibility?
Well, that's kind of science fiction, just because it will be physically kind of impossible, because that will be like the eternal cycle, and we're not creating enough energy so that the plant can nourish itself with that energy. There's always a need of solar energy or of nutrients coming to the system itself. But it is true, though, that the energy that we produce, it's produced in a constant way during day and night time. It's due to a lot of reasons, but basically that's one of the main interesting points, apart from just using a absolutely symbiotic resource. But it's a really interesting thing. We are creating energy in a constant day, even though it's raining or snowing.
So tell us about the potential uses for this. Where do you see this going?
Well, our goal with BIO, it's actually to merge nature and technology so that we no longer live in a city surrounded by four walls of concrete and basically having no other exit. We want to go back to the essence of what nature is and where we come from, but in another way. I mean, actually using technology and not abandoning it, but combining with it. We see the energy of the future as something that is in a constant transition. When we were talking about fossil fuels and then solar panels, they were all small transitions in order to reach a point like this where we are no longer actually covering with black panels a whole natural surface, but we're actually using that natural surface to power our cities. So the goal of Bio is actually to power our cities and our countrysides with the energy that we produce from nature itself, and not only that, but actually create a transformation in architecture with these implementations, where we are not only generating energy, but also using other technologies like the ones that I said to use plants as biological switches.
What are the chief obstacles you have to overcome to achieve that kind of future?
Well, right now, we've actually overcome the most difficult one, which took place on the first year, and was basically to scale this technology in order to make it something that we could industrialize. And it's actually one of the greatest challenges that we faced. Right now, we are basically creating new products for the specific markets that I was speaking about. And the main limitation that we have right now, it's time and financial resources, as you may suppose. But as any scientific investigation, it requires a lot of time. Right now, actually in September, we are launching the first implementation of the Bio panel, which is the placing of these batteries below the grass of parks and gardens. On January, we're placing this on agriculture for the first time. And actually, we've been since 2019 with our line of installations already changing architecture by activating lights or sounds with the touch of a plant. So it's a matter of time because we're already doing this.
So these are panels that go in the soil underneath the plants. Are there certain kinds of plants that you work best with here?
Actually, when talking about this technology, there are several environments that are okay for it. In fact, there are batteries that we have that don't even require a plant. They just work with soil and drag irrigation water or rainwater. And apart from that, when talking about which plants will produce more, basically we're talking about those plants which require more water. So, for example, if you have a papyrus or rice or something like that, those plants require more water, and you're going to have them anyway. So that's a very interesting way to actually achieve a more efficient way to maintain them. However, our system is actually done so that any kind of environment is absolutely available for them, as long as it has a little bit of humidity.
Well, there's a very complex ecosystem going on, it would seem, in the soil, under plants, all around us, whether it's mycelium or anything else, roots, etc. How do you incorporate this technology into all that's going on under the surface?
What do you mean? I mean, actually, we're talking about a technology that you just have to dig a hole in it and just place one of these panels or one of these batteries. It depends on the size it has that you have to dig more or less. But after all, it's just placing soil on top, any kind of environment or natural environment on top, and place water. And apart from that,
the roots, like the roots of the plants and other organisms in the soil, whether even small animals and et cetera that would burrow under the soil. Can you coexist with all of that going on?
It is a challenge, but we can. I mean, actually, the batteries that we have already, they are already designed for something like that. And of course, if I give you a panel and you dig a hole of 20 centimeters tall, it's not going to be enough because, for example, for a tree. But if you place grass, which is our first goal, there's not going to be any kind of problem. There are already a lot of filters there which prevent any dangerous organism like a worm or something like that to penetrate inside the panel or inside the battery.
So are you envisioning buildings or homes even having green spaces, lawns, if you will, that would generate electricity and enough to make a significant impact here?
Absolutely. I mean, that's the goal. Of course, it's going to be something little by little, because in the first stages, we're just going to focus on implementations in architecture for streets and cities, for malls, airports, things that are more business to business. But little by little, and after implementing this in agriculture, our goal is specifically just what you said, that any family can actually purchase one of these systems to place them in your garden. Sorry.
Is this only appropriate in certain climates?
Actually, it's something that we are testing right now. Of course, it's going to be ready for the continental climate and the Mediterranean climate, but we don't really know how it's going to react in extreme environments. So it's something that we already need to test. But it's true that a good reference is that as long as the plants are alive, you're not really going to have a problem, because the microorganisms that we are using for this reaction are way more resilient than the plants themselves.
Really, really interesting. So when do you expect this will be available commercially?
Well, as I said, we've been already selling one of our lines, which is the Bio Installations line, since 2019. Our next product, which is the Biosensor for Agriculture, is going to be launched on 2021, 2022. The Biopanel is going to be a year after that. And when are we going to see this in an average home? It's going to take like 5 years, more or less. Could be a little bit more. It depends on how the product behaves on the market and what's the impact that it has on people.
And the realistic expectation of how much of the electricity I would consume in my home could be generated this way, what would you tell me?
Actually, once we achieve our goal of generating 1 watt per square meter, as long as you have a 100 square meter garden or a 200 square meter garden, just in case, it will be actually enough to power the average American house. And it's actually a lot, because if you make the calculations, it's like 1 watt per square meter in 100 square meter, it's 100 watts hour during the whole day. After all, it's like 2,400 watts per day, and that's actually a lot of energy.
Sounds like it has a lot of promise. We're really looking forward to this. For more information, where can people go?
Actually, just visit Biotech with 2 O's, BIOOtech.com, or just look for us in the social medias. We are actually there.
Really exciting. Again, it's Biotech, BIOOTECH.com. Pablo Vitarte, thank you for taking the time with us.
Thank you, Fred. It's been a pleasure.
Cooking with the Power of the Sun. Hi, I'm Fred Fishkin, here to tell you about the latest innovation from my friend Patrick Sherwin and his great team at GoSun Stove. The GoSun Fusion has arrived using the company's tried and true reflectors and a solar vacuum tube to get you cooking without the mess of charcoal, heavy propane tanks, or smoke. A really bright idea. And with an optional solar panel and battery storage and the ability to plug in at home or on the road, you really can use the GoSun Fusion to cook anytime and anywhere, day or night, rain or shine. I love what Patrick and his team are doing, and so will you. Want to learn more? Head to gosun.co to check out all of the company's products and innovations, and use the code TEXTINATION to save 10%. That's gosun.co.